Hello everyone, welcome to Engineering Lab. In this video, I will explain what AHP is, why engineers use it, and how it helps us make decisions when things are not directly measurable. I will also take some real examples so everything becomes clear. So let's start. And so as I have written here, AHP is basically analytical hierarchy process that's used for engineering decisions, making. That is the main purpose of AHP. So you can use it in especially like AHP stands for, as you know, analytic hierarchy process, and it's a decisions making method used when we need to choose between you can say alternatives or options or priorities criteria, especially when there is no direct measurement required. So if I ask a question, for example, question could be like which is more important, or for example, we have a problem, right? You have a problem of you have a graph that has the criteria of price and quality, you can say delivery and service, right? So and the same cases here. So as we know that the all the diagonals would be equal to 1, that is the basics. So now just we wanted to know that price or quality, which one is important? This is the question. So this looks like a simple question, but it's actually very difficult. Price is measured in money while quality is not measured in money. So how do we compare them, right? Let's say another question I am giving is delivery time. For example, delivery time is more important than service or quality. That's need to understand. These are typical engineering and management questions. We face them in supplier selections, project selections, machine selections, design decisions. So the problem that I said, let me remove this question so I can have a place. Okay, let's come to the question. Now, the core problem I would like to explain. What is the problem that has to understand? You have different criteria. You have different criteria. Sorry for my handwritings. And you have different units, such as you have service and such as you have quality. So like in engineering, many criteria have different units. For example, you have price, that is in euro. I'm sorry for miswriting. That is in euro, while you have times, for example, time that are in days, right? Or you have quality, that is subjective, right? You have risk, which is uncertain. And AHP is basically was developed to handle exactly this situation. So when we talk about these things, so we need to understand basics AHP, right? So for example, if you convert the judgments to number, that is why we do these things and how to deal these things with different units, as we said about price in euro, time in days, and you have the matrix in in different units of matrix, right? So you don't know how to deal these things, so you have different criteria to different units. You put all criteria with different units. So it means in engineering, many criteria have different units. Price is in euro and times are in days. So what we do convert judgment to numbers. So AHP convert human judgment into numerical values, and so we can calculate and compare properly, right? So if I come back to the definition of AHP and I say that what is the reason we do AHP, so analytic, that is already so basics I am teaching, means break into parts, while hierarchy means structure levels. So analytic means we break complex decisions into smaller, right? Into smaller, simpler parts, while hierarchy means we organize the decisions into level, like a tree. For example, this is 2, 1, this is 3, 2, 5, 4, no wait, 7, 6. So you put it or just like a tree or hierarchy tree. You put this is hierarchy tree and you reach to the final decisions. That is engineering tree. So if I go with hierarchy tree with good example, so I can say like this. Let me, okay, now you can say this is the goal, right? And you have 3 criterias. One is just say price, one is quality, and another is delivery. And it has alternative. So if I say that like this, this you can say A, B, C, A, B, C, C, right? So this structure is the heart of AHP. First we define the goal, which I can write like this. I can say here, first we define the goal, then we list the criterias. This is the goal, and criteria, right? Then we list alternatives. Like these whole. So this is the AHP. AHP always starts with structure before calculation. You always focus on these things. AHP always starts with the structure. So this is called AHP. This is the structure. Now you would think there is more concepts that is called pairwise comparison. Pairwise comparison, let's go now. That means compare two at a time. Compare two at a time. You can write compare two at a time. Instead of comparing everything at once, AHP compares only two elements at a time. Humans are much better at making relative judgment than absolutes. This is what AHP is doing. Like, it's easier to say quality is more important than price than assign an absolute number to quality. So there is a scale that's called Sati scale. I can write in blue for better understanding, and that is called Sati scale. You can find everywhere on internet, on Google, when you just search Sati scale, so you will get it. And this scale is basically proposed by Thomas Sati, the creator of AHP, and it translates words like slightly more important or strongly more important into numbers. I can just write you that, one, according to Sati scale, 1 is equal importance, right? 2, we will consider all the odd numbers, so it would be easy for us. 3, we will say according to Sati scale, it is moderate importance. 5, strong. 'You can find the scale through Google easily by searching Thomas Sati or Sati scale. You can get it easily. That is something already proposed, so you don't need to change it. Very strong is 7 importance, and 9, that is extreme importance. So if I say about 2, 4, 6 and 8 as well, so these are intermediate values. So like if you write or no, it doesn't make sense. Like you can add it inside, like you can include it in your that would be a part of our matrix, but like these are intermediate: 2, 4, 6, 8. So this scale was proposed by Sati. That's full name is Thomas Sati, the creator of AHP. It translates words like slightly more, as we wrote here, or strongly more important to numbers. Why numbers? So once judgments are numerical, we can apply mathematics. As we discussed before, that why we needed AHP based on changing those different units, convert different units to a number, and then working on it through AHP. So let's say let's take simple example with the 3 criteria. I can say example and 3 criteria, right? So let's do it so we will understand it better. We have 3 criteria. We have criteria 1 is price, criteria 2 is quality, criteria 3 is delivery, right? Now say judgment, allowed and write them. Suppose the decisions maker says that the quality, I can say I'm a decision maker. It depends on me. At this time I'm working on this case. So I say that quality is more important or is strongly more important than price. So I can give it 5 because if you look here, strong importance, it's coming. So I give 5, or you can do directly in matrix. For example, you have a matrix, you have price, quality, delivery. Here price, quality, delivery. Now if you look, price, if I say quality is more important than price, I give it 5. Then I said delivery is moderately more important than price, I can say 3. And quality is slightly important than delivery, just 2. So now, while as you can see, you have to complete the matrix, right? So diagonal is always 1, as you can see, diagonals is always 1. Then the rest is that because the reason why it's shown, because an element compared to itself is equally important. So price versus price is equally important, while quality and versus quality, delivery versus delivery is equal important. So if you look, if Q compared to P is 5, then P compared to Q is 1/5. If these compare to this one, okay, so what would be P is 1/5, because that is the reciprocal. This is called reciprocal property of AHP. Reciprocal means inverse. 5 and 1/5 are reciprocals. So when we look also for D, delivery versus quality, so we said that quality versus delivery was 2, so this would be 1/2 and this would be 1/3. So the matrix is completed. Now the matrix capture human thinking, mean my thinking in mathematical form. It doesn't give weights yet, it only store preferences. So if I say that matrix in this case is not equal to weights. To get weights, we need calculation method. This is where eigenvector and geometric mean come in, but that's for the next video. We will continue from next video. In the next video, I will explain how we extract weights from this matrix using the eigenvector method and the geometric mean method. If you want to understand AHP properly, that video is essential. Subscribe to Engineering Lab and I will see you in the next lesson. Thank you.